Hello, and welcome to this video about developing teachers' digital competencies. This video is part of the Digi-Science project, and my name is Leo Seaman. I'm an associate professor of educational technology at the University of Tartu in Estonia. And what I want to talk to you about today is that during the COVID-19 lockdowns, we as teachers had some serious challenges. That there was this sudden shift to online and distance learning. And in addition to my university position, I was also teaching middle school students at schools during this time. And here's a screenshot of my Zoom video lesson. And you can see that I'm the only one who was sharing my video, that the other students had various reasons why they didn't want to share their video. And so as a teacher, I sometimes felt like I'm talking to these kind of empty boxes. And so part of this Digi-Science project is how could we better prepare for these kind of online learning situations? And so in this case, we also kind of some other emerging challenges for teachers is this kind of the ChatGPT, artificial intelligence, that will the chatbots now replace teachers in the school classrooms? And what COVID-19 kind of taught me was that what was missing a lot was this kind of social interaction and collaboration. And really, I wasn't prepared for making these collaborative, social, interactive type of lessons online. And so this is something we want to share to you, teachers, is how can you better use digital technologies for collaboration and promoting kind of social interactions. This is one part of our project. And so one example here, I want to tell you that research shows that for collaboration to be useful and effective is that the activity itself has to set up a condition of what's called positive interdependence. And in the case where we want to use technology, how can digital tools be used to create this kind of interdependence condition, which simply means that the students who are collaborating, they feel like their success depends on the success of their collaborators. And so they're dependent on each other. And then the positive part is kind of reinforcing that they're a team and they have to work together to be successful. And so kind of a more formal definition is positive interdependence is the perception that we are linked with others in a way so that we cannot succeed unless they do. And an example here of digital kind of technologies that could promote this positive interdependence is if we look at this simulation from the GoLabs site. And so in this case, I want to look for a lab that's called, maybe I'll do a search here for the Seesaw or collaborative Seesaw lab. And the way this simulation works is that students, if I do a preview here, that students get links to two different versions of the simulation. And what they have to do is they have to enter the same chat room number so that, or at least that they can, so let's say 15 here, is that what you see here is this interdependence condition is achieved that a student here can place objects on the left side, but they cannot place objects on the right side. That in this case, the task which relates to kind of balancing the seesaw requires kind of, well, you need to place objects on both sides of the seesaw to explore different combinations. And so the way this simulation works is that this first student who sees the left, or can control the left side of the seesaw, has to share objects with the second student. And then they can start to explore different conditions to see, okay, whether or not the seesaw can be balanced. And so in this case, kind of it can be a trial and error. But what this activity itself elicits is that students communicate with each other and coordinate their actions. And so in this case, if it's not COVID-19 times where they're at home and you don't have to make kind of breakout rooms, in the classroom, they can simply use their phones and talk to each other face to face about kind of, okay, what do we have to do? Okay, let's coordinate our actions. And in this case, this is a way of using digital technology to create this case or this situation condition of positive interdependence. In general, kind of this GoLab learning environment kind of offers these digital resources that can be used for teaching. And also, if teachers want to make digital lessons, then there's also corresponding the GRASP authoring platform where the teachers can kind of also create lessons that integrate those digital tools. In terms of structure, a lot of times digital activities in science can be structured very well using what's called this inquiry cycle. So this inquiry cycle here in this picture, it has 5 major phases, starting here from orientation, then conceptualization, then investigation, then conclusion. And then this 5th phase is always interacting with these other 4 major phases, this discussion phase that involves communication and reflection. And then this inquiry cycle was created from kind of a research paper, kind of a highly cited paper here called Phases of Inquiry-Based Learning, Definitions and the Inquiry Cycle. And maybe I'll point out, maybe one important thing here is this in orientation is kind of where you get the students motivated to learn about the topic. But this second phase, you can see that there's 2 arrows. And so I'll briefly explain why there's 2 arrows is that this depends on the prior preparation and prior knowledge of the students. That in the case where students don't have a lot of prior knowledge about a topic, then it's best to go through this left arrow to the questioning phase, where students ask questions or generate questions. However, if the students do have some prior knowledge, then it's preferred to go through this hypothesis generation phase, where students actually kind of try to think about what's a plausible explanation to explain a phenomena and generate a hypothesis that will be tested. And so these 2 different paths, they correspond roughly to kind of a inductive or deductive approach to the science lesson. And you can kind of explore more from kind of this research paper, or from the GoLab's support website also has more descriptions about this inquiry cycle for structuring inquiry. In terms of digital competencies, kind of there are certain digital tools that support these different phases of inquiry or of scientific inquiry. And in this case, our project, the Digi-Science project, has worked out kind of some suggested tools that are useful for these different phases. And so our website is at digi-science.ea.gr. And let me open this up for you so you can see, kind of see that here's the website. And if you want to find out about the digital tools that support inquiry, we go down here for Developing Teachers' Digital Competencies, click on Access Our Digital Competencies Support Package. And in this case, we scroll down a little bit and go to this one about online tools. Access a dedicated collection of ICT tools designed for educators. And when you click on this, you'll see this nice visualization in generally, and then we can click on IC tools by inquiry phases. And here you can see examples of useful digital tools that can be used for these different phases of inquiry-based learning. And so this is kind of an important thing that I think will help teachers kind of effectively use digital tools for inquiry science learning. Thank you very much.